Unlocking the Mysteries, The Fascinating Facts of Isaac Newton. Isaac Newton's birth under the Julian calendar on January 4, 1643, transitions to January 25 in the Gregorian calendar, reflecting a shift in timekeeping methods. This adjustment marks a curious footnote in the life of a man who fundamentally altered our perception of time and space through his groundbreaking work. Newton's formulation of the laws of motion and universal gravitation was a monumental leap in our understanding of the physical universe. His insights into the forces that govern movement and attraction laid the foundation for classical mechanics, revolutionizing science and setting the stage for future discoveries. Independently inventing calculus at the same time as German mathematician Gottfried Wilhelm Leibniz, Newton propelled mathematics forward. This simultaneous invention sparked debates over priority, but more importantly, it provided a powerful tool for describing the natural world, shaping the course of mathematical and scientific advancement. Philosophiae Naturalis Principia Mathematica, published in 1687, stands as a towering achievement in the history of science. Newton's book not only introduced the laws of motion and universal gravitation, but also set a new standard for the integration and application of mathematical principles to physical phenomena. In 1668, Newton constructed the first practical reflecting telescope, revolutionizing astronomy by significantly improving the clarity and reach of celestial observations. This invention, known as the Newtonian telescope, underscored his genius in practical experimentation and theoretical brilliance, leaving a lasting impact on the field of astronomy. Isaac Newton's groundbreaking work was momentarily overshadowed by a nervous breakdown in 1693, an event some historians link to mercury poisoning. His involvement in alchemical experiments, known for their hazardous materials, likely contributed to this health crisis, showcasing the physical toll of his relentless pursuit of knowledge. Despite his towering achievements in physics and mathematics, Newton's passion for alchemy often drew him away from the mainstream sciences. He penned more on alchemical practices than on any of his other research areas. This aspect of his life illustrates a profound curiosity that went beyond the visible and calculable. Newton's political contributions were as unique as his scientific ones. Representing the University of Cambridge as a member of Parliament, his tenure was notably quiet. Legend has it, his only recorded request was for a window to be closed, a quirky footnote in an otherwise monumental career. In 1705, Newton's scientific and mathematical contributions were recognized in an extraordinary manner. He was knighted by Queen Anne. This honor made him Sir Isaac Newton, marking one of the first times a scientist was knighted for their contributions to knowledge and understanding, a testament to his unparalleled influence. Newton's work not only revolutionized science but also laid the foundational stones for the Enlightenment. This period was marked by a surge in emphasis on reason and scientific inquiry. Newton's laws of motion and universal gravitation, coupled with his commitment to empirical evidence, significantly contributed to shaping this era of intellectual flourishing. Isaac Newton's profound religious beliefs deeply influenced his scientific endeavors. He saw his work as a way to understand the divine, meticulously working to reconcile the laws of nature with biblical scripture. Newton's extensive writings on biblical chronology and prophecy reflect his quest to harmonize faith and reason, illustrating his conviction that the universe's secrets were encoded in the sacred texts. Newton's famous anecdote involving a falling apple led to his groundbreaking thoughts on the law of gravitation. This story, popularized by Voltaire, who heard it from Newton's niece, encapsulates Newton's approach to science, observing the natural world and translating those observations into universal laws. It's a testament to his belief in a rational, orderly universe governed by discernible principles. Despite being a staunch proponent of rationalism and the scientific method, Newton harbored a deep interest in Arianism, rejecting the traditional Christian doctrine of the Holy Trinity. This controversial stance placed him at odds with mainstream Christian theology of his time, revealing a complex man who dared to question established beliefs. Newton's fascination with alchemy and the pursuit of the philosopher's stone reveal another layer of his complex persona. While his contributions to physics and mathematics are well documented, his alchemical research reflects a relentless quest for knowledge, spanning the tangible to the mystical. Newton's foray into alchemy illustrates his insatiable curiosity and belief in the transformational power of science. Appointed the Lucasian Professor of Mathematics at Cambridge in 1669, Newton held this prestigious position for 26 years, shaping the minds of future scientists. This role allowed him to further his research and teaching in mathematics, significantly impacting the field. His tenure is a testament to his profound influence on the academic and scientific community. Isaac Newton's three laws of motion stand as monumental pillars in the realm of modern physics, a testament to his unparalleled genius. These principles, introduced over 3 centuries ago, have not only withstood the test of time but have also formed the foundational framework upon which much of contemporary physics is built. Newton's first law, often referred to as the law of inertia, posits that an object will remain at rest or in uniform motion unless acted upon by an external force. This concept revolutionized the way we understand motion and rest, setting the stage for further groundbreaking discoveries. The second law, which introduces the concept of force, articulates that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. This law provided a quantitative description of how forces affect the motion of objects, offering a powerful tool for predicting the outcome of applying a certain force. It's a principle that finds application in every corner of the physical world, from the engineering of bridges and vehicles to the trajectories of planets. Newton's third law, known for its simplicity and profound truth, states that for every action, there is an equal and opposite reaction. This law underscores the interconnectedness of forces and has profound implications for understanding the nature of interactions between objects. It's a principle that permeates a vast array of scientific disciplines, illustrating the universality of Newton's insights. In 1696, Newton's appointment as Warden of the Royal Mint marked a significant shift in his career, yet it was a role he embraced with characteristic zeal. His reforms of England's currency and his relentless pursuit of counterfeiters underscored his commitment to precision and integrity. This period of his life, though seemingly detached from his scientific endeavors, reflected the same rigorous standards he applied to his scientific work. Newton's exploration of optics and his discovery that white light is composed of the same system of colors seen in the rainbow further expanded his legacy. This breakthrough not only advanced the field of optics but also demonstrated the breadth of his intellectual curiosity and his ability to draw profound insights from careful observation. His work laid the groundwork for the field of spectroscopy, illustrating his remarkable capacity to transcend the bounds of individual scientific disciplines. Isaac Newton, a towering figure in the world of science, dedicated his entire life to his work, choosing never to marry or have children. This commitment allowed him to delve deeply into his research and discoveries, unencumbered by the distractions of family life. His singular focus on science and mathematics enabled groundbreaking contributions that have stood the test of time. Despite his monumental achievements, Newton's life was not without its personal challenges. He suffered from periods of depression, with 2 significant breakdowns that marked his life's journey. These episodes of mental health struggles underscore the immense pressure and intensity of his work, highlighting the human aspect of this scientific giant. Newton's contributions extended beyond the confines of academia, as he took on the role of President of the Royal Society in 1703. Under his leadership, the Society flourished, reinforcing its position as a cornerstone of scientific inquiry and innovation. His presidency until his death cemented his legacy as not only a brilliant scientist but also a revered leader in the scientific community. Upon his death in 1727, Newton left behind an estate of considerable value, evidence of his successful career outside his scientific endeavors. His financial success was a testament to his intelligence and versatility, managing to excel in both the realms of science and finance. This aspect of his life offers a glimpse into his ability to apply his analytical mind beyond the laboratory. Newton's interpersonal relationships, particularly his rivalries with other scientists such as Robert Hooke and Gottfried Wilhelm Leibniz, reveal a fiercely competitive nature. These rivalries, most notably with Leibniz over the invention of calculus, were marked by intense debate and conflict, showcasing the passionate defense of his work and intellectual property. These conflicts, while contentious, also spurred further innovation and discussion within the scientific community. Isaac Newton's foray into alchemy and the occult has long intrigued historians and scientists. His extensive writings on these subjects reveal a man deeply fascinated by the unknown, challenging the typical image of a purely rational scientist. Newton's alchemical experiments aimed at uncovering nature's hidden laws, blending science with mysticism. Despite his monumental contributions to physics and mathematics, Newton's humility remained profound. He famously remarked on his own achievements, suggesting that his discoveries were made by building upon the knowledge of those who came before him. This humility underscores the collaborative nature of scientific discovery and innovation. Newton's posthumous diagnosis of Asperger's syndrome by some researchers offers a glimpse into his personality. This speculation is based on his intense focus on work, limited social interactions, and the singular nature of his pursuits. It paints a picture of a man whose extraordinary mind was always at work, perhaps at the cost of conventional social engagements. Among Newton's more speculative beliefs was his prediction regarding the end of the world. Using his interpretation of the Bible, he suggested that the apocalypse would not occur before 2060. This assertion reflects Newton's deep interest in theology and his attempt to reconcile religious beliefs with scientific understanding. As one of the early proponents of the mechanical universe concept, Newton revolutionized how humanity perceives its surroundings. He saw the universe as governed by precise laws of nature, a perspective that laid the groundwork for the Enlightenment and propelled scientific inquiry into new realms. This view underscored the predictability and rationality of the physical world, influencing generations of scientists and philosophers. Isaac Newton saw the study of nature as a divine exploration, believing it to be the script through which God communicated the workings of the universe. To him, every law and every motion unveiled a part of the celestial design, making science a sacred act of understanding the divine will. With the creation of the Newtonian telescope, Newton revolutionized astronomy. This invention, simple yet powerful, allowed for clearer and more distant views of the cosmos than ever before. It opened up the heavens to amateur stargazers and professional astronomers alike, making the study of the stars and planets more accessible. Newton's impact stretched into the Enlightenment, profoundly influencing thinkers like John Locke and Voltaire. His work laid the foundations for an era that valued reason and empirical evidence, shaping philosophical thought. The Enlightenment's emphasis on knowledge and individualism can be traced back to Newton's ideas and scientific achievements. Through his experiments with light and prisms, Newton birthed the field of spectroscopy. This breakthrough allowed scientists to understand the composition of light and laid the groundwork for future discoveries in physics and chemistry. Spectroscopy became a crucial tool for analyzing materials and understanding the universe's vast mysteries. Lastly, Newton's formulation of the laws of motion and universal gravitation played a crucial role in the success of space missions, including lunar expeditions. These principles guided the path for spacecraft, proving that his theories not only explained the earthly but also the celestial, bridging the gap between man and the cosmos. Isaac Newton's groundbreaking work on calculus remained largely secretive until his contemporary, Gottfried Wilhelm Leibniz, published similar theories. This sparked a fierce and historic dispute over who truly originated calculus. Newton, fiercely protective of his work, found himself embroiled in a battle that strained relationships within the scientific community. Despite his monumental public contributions to science and mathematics, Newton's private papers revealed a different side to the man. They showed him as someone deeply immersed in mysticism and the study of ancient cultures. This aspect of Newton suggests a complexity that went far beyond his scientific achievements, illuminating a relentless pursuit of knowledge in all its forms. The story of Newton and the apple has become a symbol of scientific inspiration, yet it misrepresents the nature of his genius. Rather than a singular moment of revelation, Newton's theories on gravity were the result of years of meticulous experimentation and contemplation. This narrative underscores the reality of scientific discovery as a rigorous and prolonged endeavor. Newton's influence stretched far beyond the realm of science. His mathematical principles not only revolutionized physics but also laid foundational concepts that influenced modern economics and political theory. This demonstrates Newton's extraordinary ability to see the underlying patterns and laws that govern not just the natural world but human society as well. More than 3 centuries after his death, Isaac Newton's theories and discoveries continue to impact our daily lives. His unparalleled genius has shaped our understanding of the universe, influencing everything from space exploration to the technology we use every day. Newton's legacy is a testament to the enduring power of curiosity and intellect.